Hi, my name is Muhammad Haziq bin Shukri, mental list number 312112, and now I'm going to talk about question 1a. For question 1a, we are given the function y equal to fx equal to 2x cubed minus 9x squared plus 12x minus 4. Our objective is to find the intervals where the function is increasing and decreasing. First, we calculate the first derivative of the function. Differentiating fx, we obtain f prime x equal to 6x squared minus 18x plus 12. This expression can be factorized as f prime x equal to 6 bracket x minus 1 bracket x minus 2. Next, we find the critical point by setting the first derivative equal to 0. Solving 6 bracket x minus 1 x minus 2 equal to 0, we get x is equal to 1 and x is equal to 2. Using the sign diagram shown on the slide, we analyze the sign of f prime x. The derivative is positive when x is less than 1. Negative between 1 and 2, and positive again when x is greater than 2. Therefore, the function is increasing on the tables negative infinity, 1, and 2 infinity, and decreasing on the interval 1 and 2. That's all for question 1a.
Now I will explain the question 1b. Demand function given is P of Q equals to 100 minus 4Q. Total revenue is calculated as price times quantity. Substitute the demand function R of Q equals to 100 minus 4Q times Q equals to 100Q minus 4Q squared. Next, determine the concavity of the revenue functions. R price of Q equals to 100Q minus XQ. R double price of Q equals to negative X. Negative X is less than 0, so the revenue functions is concave downward. To find the output level at which total revenue is maximum, we set the first derivative equals to 0. 100 minus XQ equals to 0. Q equals to 12.5. Now we substitute the Q equals to 12.5 into the total revenue function equals to 625. Revenue is maximum at Q equals to 12.5 unit with maximum revenue at 625. The firm should be produce 12.5 unit to maximum total revenue. Beyond this output level, the price reduction required to sell additional unit reduce total revenue.
For question 2a, we are given the total cost function Tc is equal to 100 plus 2q plus 0.1 q squared, where q represents the quantity of unit produced. First, we calculate the marginal cost. Marginal cost is defined as the first derivative of total cost with respect to output q. By differentiating the total cost function, we obtain mc is equal to 2 plus 0.2q. Next, we determine whether the marginal cost is increasing or decreasing as production increases. To do this, we take the derivative of the marginal cost function. The derivative of mc with respect to q is mc prime equal to 0.2. Since the value is positive, it shows the marginal cost increases as output increases. Therefore, we conclude that the company experiences an increasing marginal cost as the level of production rises. That's all for question 2a.
Hi, Assalamualaikum. My name is Siti Hajapati Shamsul. My metric number is 312143, and I'm going to answer question number 2b. So the first one is find the quantity that maximizes revenue. RQ equals to P times Q equals to 100e power 0.05q, and then we have to find the R prime Q equals to 100e minus 0.05q in bracket 1 minus 0.05q, and then we have to equals that to 0. You get Q equals to 20. For question number 2, determine the intervals where total revenue is increasing and decreasing. We get R prime Q equals to 100e minus 0.05q in bracket 1 minus 0.05q bigger than 0. So for that we get the total revenue increasing on 0, 20. And the total revenue is decreasing on 20, infinity. That's all. Thank you.
Hi, my name is Pang Shenwen and matrix number 312146. And now I will discuss about question 3. 3A question is, a local manufacturing company aims to maximize its profit. The company's demand function is Q minus 90 plus 2P equals to 0, while its average cost function is AC equals to Q squared minus 8Q plus 57 plus 2 over Q. Roman 1 is find the value of Q for which the profit is maximum. First, we need to express price in term Q. So Q minus 90 plus 2P equals to 0. 2P equals to 90 minus Q. P equals to 45 minus 0.5 Q. Now we need to find the revenue. Revenue equals to P times Q. Q bracket 45 minus 0.5 Q equals to 45Q minus 0.5 Q squared. Then we need to find total cost. Total cost equals to average cost times Q. So Q bracket Q squared minus 8Q plus 57 plus 2 over Q equals to Q cubed minus 8Q squared plus 57Q plus 2. Then we need to find the profit. Profit equals to revenue minus total cost. PQ equals to 45Q minus 0.5Q squared minus Q cubed minus 8Q squared plus 57Q plus 2. So it will equals to negative Q cubed plus 7.5Q squared minus 12Q, then equals to negative Q cubed minus 0.5Q squared plus 8Q squared plus 45Q minus 7 minus 57Q minus 2, then equals to negative Q cubed plus 7.5Q squared minus 12Q minus 2. The next step is FOC, differentiate profit with respect to Q. P prime Q equals to negative 3Q squared plus 15Q minus 12 equals to 0. Then we divide the negative 3 equals to Q squared plus 5Q plus 4 equals to 0. Then Q minus 1 bracket Q minus 4 equals to 0. Q minus 1 equals to 0. Then we move the negative 1 to the right hand side. Then Q equals to 0 plus 1. Then Q equals to 1. The next one is Q minus 4 equals to 0. We move the negative 4 to the right hand side. Then is Q equals to 0 plus 4, then Q equals to 4. Next, the Roman 2 is using the second order condition SOC, prove that the quantity in Roman 1 result in a maximum profit. Prove quantity get with using SOC. Find second derivative. P double prime bracket Q equals to negative 6Q plus 15. If Q equals to 1, P double prime times 1 equals to 6 times 1 plus 15. Negative 6 plus 15, then the answer is 9. 9 is larger than 0 at minimum point. If Q equals to 4, P double prime times 4 equals to negative 6 times 4 plus 15 equals to negative 24 plus 15. The answer is negative 9. Negative 9 is smaller than 0 at maximum point. Profit maximized at Q equals to 4, the slope will go upward.